The question 9 is applying the chain rule for differentiation. Here we have been told to find the derivative for this given function here, h of x equals function of g of x. And we need to find the h prime or the derivative of h for 1. Now this cannot be solved in calculator. We have to solve it using the differentiation rules. That's mainly the chain rule. Now there are lots of values given. That is fine, you can ignore that for now. Let's first solve the derivative, the h prime of x, because we have h of x, right? So the derivative over here, h prime of x would be equal to, now this is the outer function f. The outermost function is this f. So first derive it, f prime of g of x. Then what do we need to do? Derive whatever is inside, that is g prime of x. So this is the condition over here, what we got. Now then, what do we know here? We know f prime of x, right? But we need to solve for 1. So instead of x, we have to put everywhere 1. H prime of 1. And over here equals to f prime of g of 1. Instead of x, everywhere you need to put 1. That's it. Then g prime of 1. Now let us substitute. We need to find this. We do not know. That is what we are finding in this question. H prime of 1. But here we know that g prime of 1. Do we know that value? Yeah, we know g prime of 1 is minus 2, right? So this is minus 2. Okay, very easy. What is g prime of 1? G of 1, sorry, it's not prime, g of 1. We know it is 2. Okay, so that's going to be f prime of 2. But still it's not over. We know g of 1, that's only the original function. G of 1 is 2. We substituted instead of g of 1 as 2, and then g prime of 1 is minus 2. But now there is still one more thing. F prime of 2 is formed. What is f prime of 2? That's 3. So here now, h prime of 1 will be equal to this f prime of 2. We know the answer is 3 times minus 2. So the answer will be negative 6. 3 times 2 is negative 6. So it's first just derive it up, then input whatever is known. This is how we basically solve it. I hope this is clear. Let's do the next one as well. We can use the same one over here because the derivation doesn't change. It's the same condition, right? So what I will do is only these parts I can change and write it now. That is h prime of x. When you derive it, it will be equal to f prime of g of x multiplied by g prime of x. That means whatever is inside, you derive it. I'll just give an example in terms of functions. If you had sine 2x here. Now what happens? You derive sine first, it will be minus cosine 2x, and then you derive whatever is inside. 2x derivative is 2, right? So this is the same thing what is happening over here now. I hope that is clear. Now here then, let's look what we need to find is 2. Instead of h prime of 1, we have to put h prime of 2. So this becomes 2 as well, and this is 2. Let's see what are the values known to us. First, we need g of 2. Do we have? Yes, g of 2 is known. F prime of 3 is what we need. We need. See, g of 2 is 3, isn't it? So instead of g of 2, we write 3 multiplied with g prime of 2. Do we have? Yes, that is 4. What is f prime of 3? That's over here. So we need to substitute this entire thing. F prime of 3 is minus 3 times 4. So we'll have negative 12. That is h prime of 2. That's it. So this is how we basically solve it. We got minus 6 in the first case and now minus 12 in the second case. Now here we have some interesting problems. A function f is an even function if f of minus x is equal to f of x for all x, and it is odd function if this negative sign remains, it will come out of the function for all x. We need to prove the derivative of an even function is odd and the derivative of odd function is even. Okay, let's just make sense of this. First of all, they have told what is even function. Even function would be this one given. F of minus x will be equal to f of x. The minus sign is dissolved. Whereas odd function also is given. Odd function is here f of negative x, that will be equal to minus f of x. Now then, if you know so much, can we just find the derivative directly, because they are asking us to prove the derivative of an even function. Let me write over here what would be the condition. If we derive this even function, derivative of in now, when we derive this, what do we must get? We must get odd. That means, see, odd function just has a minus sign outside. Right here, we must have minus basically. So this is the thing. This is what they are saying. If we derive the even function, this is the even function. If we derive it over here, if we derive this minus x, we must get minus f of x. Whereas if we derive the odd function, when we derive this, we must get even function. That means the minus sign is dissolved. Okay? So this is the condition. Now here one thing is missing. Sorry, I missed one thing. Derive both the sides. This derive. Now derivation of even function must be odd and derivation of odd function must be even. This is the condition they have specified to us. Now let us see whether this really is true. Let me go back to the color. Here just derive on both the sides. What's going to happen? F derivative of minus x. Now here minus x also needs to be derived. It will be minus 1. That is derivative of f of x, right? Derivative of this. Now then, this minus, right? Let's take it to the other side. Or just multiply through both the sides by minus 1. You will get f prime of minus x. This minus 1 goes off, but here there'll be minus f prime of x. Absolutely, right? When we derive the even function, we get an odd function. This is odd. See, even function means f of minus x must be equal to f of x. Whereas odd function f of minus x would be equal to minus f of x. Now when we derive this function here, we are getting minus f derivative of x. That means, yes, this is odd because minus is there outside. Let's derive this one now. When we derive over here, f prime of minus x multiplied by minus 1 will be equal to minus f prime of x. Now multiply all the sides. See, minus 1 is there. Multiply throughout by minus 1, it's going to be f prime of minus x. That will be equal to f prime of x. Now this is right side even, right? So this is hence proved. Yes, that is true. And we can tell this is a true statement. By the way, this is a electronic part. You will have to choose from options. So proving problems do not come. Problems like this will not come, but this is the understanding. Odd function, when you derive it, you will get a even function. When you derive, you'll get odd function. The derivative of odd functions would be even. Now then, see over here, the same thing is told. So that's the thing. You can just follow this one, which is much easier to understand. And even this problem, again, I don't think this will come, but anyways, let's go through this. If the graph of a differentiable function f is symmetric about the line x is equal to a, okay, it's symmetry. So what comes to my mind is a parabola, because it's very easy to remember a parabola, right? Now imagine this x is equal to a, this is the line, okay? This is the line. What can you say about the symmetry of graph of f derivative? Now here, what does symmetry mean? F of x will be equal to f of x. Sorry, now this is given as a. Let me take it as a. Now imagine if I go to 1. What is the y value? It will be the same y value at minus 1, isn't it? Or if I choose this point, whatever is there, it will be symmetrical to the opposite side as well. So if I go any value here, say minus x, it will be equal to the plus x value. Now this a line, if I add over here, or if I subtract here, this must be equal. Then only it is symmetry, because this function f is symmetrical, isn't it? Now the first one is a, or you can write it as x and a, but since they mentioned x is a, I've taken it like that. Here it is a plus x and a minus x. I hope this much is completely clear. Now then, we need to find the derivative, right? Let's just derive this function and see what happens. I will derive this over here. A plus x. What is the derivative of x? It's 1, so I'm not going to write. Multiplying by 1, it's the same thing. Now here as well, derivative of a minus x. And then what happens? Derivative of minus x will be minus 1. So this is the thing. Let me derive it. Now let me simplify it, sorry. The derivative of the symmetrical function will be equal to minus of derivative of a minus x. Now basically what happened is the same derivative, both the sides are derivative, but this is an odd function. The derivative would be odd function. So basically what happens is, if you say a point f of x, this side I have taken a point of phi, y is phi, right? This will also be phi, but on the other scale. Okay, it will be down phi. That'll be down. So this will be minus phi. Why? Because if this is phi, if derivative function is phi, your minus is this, so it will be minus phi. So that is the thing. Now basically that's it. So that is what we have over here. So you can see the derivative would be minus f of a. This is called point symmetry, I guess. But just if you do this, that's enough. But this is again not, we do not use proving problems for electronic part. But if you understand the concept, that's more than enough over here. Now these problems are important. Let's solve these all. Here, f of x squared is given, f of x the whole square is given, and function multiplied by f of x is given. There are two functions here. Now they are not given in terms of x or cosine or sine, so we cannot use calculator over here. We need to derive it manually. Calculator may work for some problems, but if you have similar options, it cannot be used. So please don't use calculator. Let's solve this up. F derivative, first thing, what is the outer function? It's the f, right? F prime of x squared. Now what is the inner function derivative? It will be 2x. That's the answer. Now here outer function is 2, so it will be 2 f of x. Then what is the inner function? Derivative of f of x. That's it. Now what about this? It is two functions, right? Oh sorry, this one is outside and then multiplied to this function. In the sense, when we derive this, it's going to be f prime of f of x. Okay, that's outside derived. Then whatever is inside, derive f of x, and then derivation of x is 1 basically. So it's chain rule over here. I hope that's clear. See here it's 2x. They have rearranged and written it's 2x f prime of x squared. Here it's 2 times f of x, f prime of x, and lastly we have f prime of f of x times f prime of x. I hope this much is clear. So here f prime outside, then whatever is inside, then again we have to derive inside thing. That's it. Now if at all this x was something else, x power 2, then over here it will be x power 2, then we derive again x power 2, and then we have to write 2x. What I mean is, if at all it was a complicated problem like this, then first we derive outside function, it will be f of x squared, done. F prime, this is done. Now what is inside? This f of x squared. So it will be f prime of x squared, done. But then we have to multiply whatever is the derivative over here, it will be 2x. So there will be 3 parts. So that's how we solve it, but that's just my own question I gave you. This is all over here, done over here. Now over here as well is the same thing. What is the rule for square root? I hope you remember square root x derivative would be 1 by 2 root x. So directly I can write, so first one, outer function f prime of square root x multiplied by 1 by 2 square root x. What about this one? It will be 1 by square root f of x multiplied by 2 is there, 1 by 2 square root x, right? Here instead of x we have this entire term, see square root x, right? But over here we have f of x, so instead of x I just put f of x. But then I have to derive whatever is the function f of x. Now what about over here? See, this is important because now this is the outer function, yes. I will write f derivative of x, f of x, that's done. But now when I derive the inside function, there are two terms, x and f of x. I have to use the product rule. If it was a times b, a derivative, it will be a prime b plus a b prime. This is the rule which I'm going to use. Here, derivative of x will be 1 times f of x as it is the second term, plus a term is as it is, and then I write f prime of x. This is the thing. And then what we write is f prime of x, f of x. Over here, f of x plus x f prime of x. I think so we can leave it like this because they have not asked you to simplify to the lowest. This is enough. No need of multiplying again inside. I guess this is the correct answer. Yes. Over here as well, yes, this is the correct answer. And over here, we're getting f prime of x, f of x. And yes, this is it. Usually we don't go to multiply this. It's already simplified, so leave it like that. And here as well, f of 1 by x. What is the derivative of 1 by x? D by dx of 1 by x will be equal to minus 1 by x squared. This is the answer. This is the derivative rule. Now here, first f prime of 1 by x multiplied by minus 1 by x squared. That's the answer. Here we have 1 by f of x. So it's minus 1 by f of x squared times f prime of x. Because first I do 1 by x. Instead of x, I have f of x. That's fine. Minus 1 by x squared. Then whatever is this x term, I have to derive it. So derivation of the x term would be x itself. Sorry, f prime of x itself. And now over here we have quotient rule, a divided by b, that is given as a prime b minus ab prime, divide, this is prime over here, divided by b power 2, the second below term, okay, is b. Now first one would be f prime of x by f of x. Simple. But now here it gets complicated because we need to square the below term. I'll write it like this, f of x all squared, and above derivative of x will be 1, and multiply this only f of x minus the x term as it is, and derivative of f of x is f prime of x. So that would be the answer. You should just imagine this as simple terms. Okay, you can consider this as a, solve it up and then substitute back as well, but this is much easier to understand. I mean, you can directly solve it because it's not so complicated. So here you can see it is, yeah, minus 1 by x, minus is outside, 1 by x squared, and f prime of 1 by x. Over here it was minus 1 by f of x the whole square and f prime of x. And lastly here it was f prime of x by f of x, and here we have f of x minus x f prime of x divided by f of x the whole square as it is. These are the correct answers. I hope this is clear. You can directly write it without any extra steps. And the last one over here, we have two terms. The derivative of 0 is 1 is 0 plus f prime of x squared multiplied by whatever is inside, that will be 2x. That's it. You can rearrange and write. Generally they write it like this in the answers. So choose what, once you do this, choose the correct answer. You should look into the options and choose the correct answer. What about this one? The square is outside, so it will be 2 times 1 plus f of x. Now I derive whatever is inside. 1 is 0, but this one over here will become f prime of x. That's it. Now here it is f prime of 1 plus f of x. Then again, derivation of inside, this will be 0, and we have f prime of x. So that's the answers. Chain rule is pretty simple. It's like peeling a onion. From outside you need to solve one and then go inside and then inside. That's it. So here we solve this power 2 first, then whatever is inside we try to find the derivative. So these are the answers you can see as it is. Now here what they have done is they have simplified it. No, not simplified, sorry, they have just rearranged. They have written 2 and f prime together, and this is as it is, you can see. And lastly over here as well, they have left it as it is. They have written this term first and then as it is. So that is basically the end of question 9. You need to try solving it by writing because there is no shortcut methods, there's no calculators method for this. Please make sure you solve few problems on chain rule. Once you understand how chain rule is applied, then they will be much easier.